All right, ladies, this is a discussion of how important it is to recognize what units are involved in some of these free response questions. And this goes along with the flow rate question. So you want to make sure you understand the units first, okay? So suppose you read a free response question and they give you this function, f of t. And when you read all of the words, you are able to tell that the units for f is dollars and the units for t is hour, and they tell you that f of t is dollars per hour, okay? So this is some sort of given rate, okay? If you know this, then if you are asked to find the derivative of that, you need to recognize what the units will be on that. It will be the units of f per hour again. And it is also correct if you said dollars per hour squared, but this is a little more intuitive. Dollars per hour every hour. This tells you how the dollars per hour are changing. So maybe at hour 1, you're earning $5 an hour, and maybe at hour 2, you're earning $7 an hour. So your dollars per hour are changing, all right? And also, if you are asked to take the antiderivative of the original function of f of t, then the units of this answer are going to be dollars. The AP love to give you a question where they give you this one right here and then ask you to take its derivative and do something with it, and then go back and take its antiderivative, because then they can get, you know, two different things going from one problem, okay? So the key is to pay attention to what the units are, all right? If I ask you to find the integral from a to b of f of t, you need to recognize what that's going to tell you, okay? It's going to tell you the same thing as an antiderivative in terms of units. It's going to tell you dollars. But even more specifically than that, this right here tells you the amount of change. How much does it change of the function that's in there, of f, from t equals a to t equals b? How much do the dollars change? Okay? Okay? And then the next one is, if you're asked to do this, then this part is going to give you dollars. This part is 1 over B and A are hours. Dollars. So the units on this one is going to be dollars per hour. There's your units, dollars per hour. And you should recognize this feature, 1 over B minus A times the integral from A to B. This is the average value of, this is important, whatever's right here. It's the average value of f, okay? It's the average value of f from A to B. Okay? If you compare that to this one, these are the two that people get mixed up. This one that I just did, this average value one, and this one. Okay, similar but not quite the same. Still an average value, because it's 1 over B minus A, the integral of A to B. But it's not the average value of f, it's the average value of f prime. Okay, it's the average value of f prime. And what would the units be for this? Okay, well, this part right here is going to take you back to f. The antiderivative of f prime is going to take you back to f. And the units for f are dollars per hour. And this part again is 1 over hours. So the units for this are dollars per hour, okay? This is the average value of f prime. All right, I'm going to go through a few of these generally, and then we'll do one that's got a little more context to it, all right? The second one, suppose that I tell you that g of t is gallons per minute. So there's something is flowing at a rate, gallons per minute, okay? So what would the units be if you decide you're going to take the derivative? Well, it would be the rate of change of the gallons per minute. So gallons per minute per minute. Again, you can write gallons per minute squared, and that's perfectly acceptable. And if I ask you to find the antiderivative of G back at the beginning, then when you do that, whatever your answer is, it's going to be in just plain gallons. Okay? Just plain gallons. How many gallons? All right? All right, so once again, we'll just go through and make sure that you see what the units would be on each one of these possible structures. Okay, and what they mean. One of the questions that's been showing up a lot on the AP recently is find this numerical answer and explain what it means. Okay, so we're going to try to get a handle on that. All right, if this is the definite interval, which is the antiderivative, that means the units are going to be gallons. All right, but it's from A to B. It's a definite interval, so definite interval is amount of change in G. So how much does the gallons change? Amount of change from A to B. Okay, by gallons. How many gallons was it changed? Okay. All right. This one. 1 over B minus A, the integral from A to B of G of T is going to be gallons. This is gallons, and it's going to be divided by minutes, so gallons per minute. And this is the average value of G, gallons per minute. How did the gallons change and the average value of G, gallons per minute? And one more, 1 over B minus A, times the interval from A to B of G prime is gallons per minute, that's this. Remember, the antiderivative of G prime takes you back to G. This is gallons per minute per minute. This is also the average value, but it's not the average value of G, it's the average value of G prime. Okay. So let's do one where I start with something you feel a little more comfortable with, V, which is velocity. Y'all are pretty comfortable with velocity, and the units on velocity are meters per second. It's the same thing, it's a rate of change. If I ask you to find V prime, going by what we just did, then the units are going to be meters per second, or this thing that y'all are comfortable with, physics meters per second squared. Now, V prime has another name. We are comfortable with V prime having another name, and that is acceleration. But it's also called V prime. They're the same thing. And if I take the antiderivative of V, then the units are going to be meters. And you know, if you go the antiderivative of V, you're going to get the position function. Okay? So it's got another name. The position function is often called X or Y or sometimes S. But it's got another name, but it's still related, just like those first two examples that I did. All right? So thinking through that, what would this be? The definite interval from A to B of the velocity is going to give you meters. That's the units, and it's going to be the amount of change, not the change in velocity, but the change in meters. Okay, how did the distance change? So change in position, because we happen to have this other name for the antiderivative of V. Okay, if I say 1 over B minus A times the interval from A to B, this is going to be in meters. This is divided by seconds, this is meters per second, and this is the average value of whatever's here, the average value of velocity, okay? Also known as the average velocity. I think I mentioned to you before, if it says find the average something, to throw in that word average value of, and that usually helps people get started, okay? 1 over B minus A, the interval from A to B of B prime Well, when you take the antiderivative of v prime, you get v, and then you're gonna divide it by seconds, so this is gonna be meters per second per second. This is the average value of v prime, also known as the average value of acceleration. We happen to have another name for v prime, or just the average acceleration, okay? All right, this business of one function having more than one name causes some confusion. And yet, when we do velocity and acceleration, it doesn't seem to bother us. It's okay if we can say that velocity is also the derivative of position, or acceleration is also the derivative of velocity. So that's all that this is saying. I have two functions, and I have one function, and it's got two names. It is the derivative of something, and it's also got its own name, okay? So just this problem usually comes because they're the same letter. Sometimes people make fewer mistakes when we use different letters for these, but there it is, they're the same letter. So if I say the integral, antiderivative of big F, then I am saying the antiderivative of little f prime. Those are the same thing. They are the same thing. So if I ask you to find this, you can think of this, and we know what this is, this one, right here. The antiderivative of f prime is just f. And remember, when you do antiderivatives, you have to put the plus c on there. And then if I ask you to do this, if I said, well, find the definite integral for me, you can say, well, that's exactly the same thing as this, because it's just two different names for the same function. And the antiderivative of f, little f prime, is little f. And this time, instead of plus c, I'm going to evaluate it from a to b, and that gives me f of b minus f of a. This is kind of a statement that you want to be comfortable with right here, maybe without showing that step in the middle. Whoops, that's supposed to be b. Write it correctly. F of b minus f of a. Okay? And then this statement right here is another one you want to be comfortable with. If I ask you to start with f of a and add to it the definite integral from a to b of f prime, you notice this is f, this is f prime, what is that going to give me? All right, well, this is a start value. This is some given start value at some specific place. And this, the definite integral of a rate of change, is the amount of change. So this is, what did I start with? How much did I change? This tells me what I'm going to end with, okay? All right, and for this to work out, you need this right here to be the same as this. And this right here will be the same as this, okay? This gets used a lot, right? I'll give you an example of velocity. So if you've got v of t is given, some function or some chart or some picture, some graph, and I also tell you that x of 2 is 5. I'm giving you a starting value, okay? Giving you a starting value. And I ask you to find the change in position from t equals 2 to t equals 10, right? Change in position is the antiderivative of the derivative of position, okay? The derivative of position is velocity, okay? From 2 to 10, right? And the antiderivative of velocity is position. It looks like they told us position is called x, so this is going to give us x of t, and we're going to evaluate it from 2 to 10, right? It's kind of nice if you can skip that step. It's not required, and recognize that this is just going to be plug in 10 and plug in 2 into your position function if that's given. All right. If I ask you to find well, what is x of 10? Then you say, well, I know what x of 2 is, that's what I started with, and I'm going to add to that however much it changed right here. Okay? The connection here is the start value is x, and this is the derivative of x, is x prime, this velocity. Okay? All right, let's do one that has a little bit more words in it. Okay? Given r of t is the rate of change of the radius of something, some circle somewhere. Okay? So there's a whole paragraph and you read it and it gives you a function or it gives you a graph or it gives you a table of values, the rate of change of the radius, and you determine that the units are centimeters per second. So that means that the radius is in centimeters and the time is in seconds. And also given in the problem is that at time 0, the radius is 3. Okay, and you notice that I use the lowercase r, so let me just define that to be the actual radius. Okay? All right? So they're not going to say find the definite interval from 3 to 4. Well, they might, but they're actually more likely to say find the change in the radius and give you a time interval from t equals 0 to t equals 5. Okay? So you have to think back through all those things that are possibilities. Okay? I want to find the change. That's the amount of change. And to find the amount of change, we do an antiderivative. And actually, we do a definite interval, so we go from 0 to 5. And we don't put radius in here, we put the rate of change of the radius. How fast is it changing? Take the antiderivative of that, it will take you back to the radius. And so depending on what you know, if you have a function here, or if you have a graph, you could do it with anti-definite interval, or you could do it with the radius function. Okay? As I said, find the average rate of change of the radius, and I'll do 0 to 5 again. The average rate of change of the radius. Remember that that is the average value of the rate of change. So that means 1 over b minus 7. So 1 over 5 minus 0, the interval from 0 to 5. And what you put here is whatever that says, the average rate of change. So we put the rate of change of the radius here, and that means we put this. This part right here is going to give us how much the radius changed, and this is going to say divided by 5 seconds. Okay, that's going to say divided by 5 seconds. If I asked you instead to find the average radius from t equals 0 to t equals 5, 1 over 5 minus 0 again is average value. You've got to sort of hear that word in there. Okay? The average value, the interval from 0 to 5, and what do we put in here this time? We put the radius, the little part. And that's going to tell me how much radius changed. Now this is one place where the units kind of fail us just a little bit, because it's not intuitive to think, well, what would my units be if I take the antiderivative of centimeters? That's not intuitive. But if you take the antiderivative and then you divide it by the seconds again, it's going to just take you right back to the radius. So this is going to be in centimeters. Okay, that's not the most intuitive one. Okay, and finally, if I said find the radius, what is the radius when t equals, and I pick a time, let's say I pick 3. Okay, find the radius when t equals 3. Okay, so how in the world are you supposed to do that? Well, I'm going to go all the way back to the beginning of this problem, and you're going to remember that somebody told you what the radius was at 0. That was given. So that means you have a starting point. So I can start with what the radius was at 0 and add to it the amount of change. How much does this change? And remember, if you want amount of change, you have to put the rate of change in here, okay? So when you do this, it takes it back to off. If you add it to this way, or you can put it like this. That also gets back. Okay? All right, and again, the key thing here is to make sure that this matches this. And then this, right here, tells you that you're going to get this. Okay? I'm going to write this out in general, because this is so important. If you are looking for a new value, and you are given a start value or an old value, then you're going to add the amount of change. Okay? And so that will look like this in general terms. F of B equals F of A plus the integral from A to B. And here's the key. Here's a place that people mess up. I don't put F right here. This whole thing has to have the same units as F, and so what has to go here is F prime. Okay, whatever variables are being used in that particular problem. Okay? All right, next thing. So that is it.